Hey guys, so in this part 2, I'm going to go over some more of the problems on your assessment review for Unit 3. So in part 1, we went over number 1 and 2 for the first section, and number 2 on the second section. So let's start with number 2 on the third section, where we are factoring these trinomial expressions when a does not equal 1. So we are going to do number 2. I'm actually going to go to the next page so we can answer the question set up for us. So for number 2, we had 16x squared minus 72x plus 80. So we are looking to see if we have a GCF. Looking at the numbers, 16, negative 72, and 80. Is there a GCF? Yes, our GCF is 80. Or 8, my bad, 8. So because our GCF is 8, we are going to factor out 8 from each term. So 16x squared divided by 8 is 2x squared. And we're going to take negative 72x and divide it by 8, which was our GCF, to get negative 9x. Then we're going to take 80 divided by 8 and we get positive 10. So this is how we factor out our GCF. Now, once we have factored out our GCF, does our A equal 1? So underneath our parentheses, or within our parentheses, does our A equal 1? No. What do I mean by A? If I had my y equals ax squared plus bx plus c, my A is always the coefficient of x squared. So no, it does not equal 1. So if our A does not equal 1, then we have to slide and divide. So we're going to take our 2, or our A, and slide it to our C. So now we are factoring x squared minus 9x plus 20. Now does my A equal 1? Yes, it is 1 as my coefficient of x squared. So now I can do my big X method. So I'm going to create my big X. My B is my negative 9. My C is my positive 20. And I'm looking at for two numbers that multiply to give me 20, but also add or subtract to give me 9. So I'm going to start a table. You can create a table if you need to. If you don't need to, that's fine. But you start with 1. So 1 times what gives you 20? Well, 20. Then you go to 2. 2 times 10 gives you 20. Then can 3 go into 20 evenly? No. Can 4 go into 20 evenly? Yes. 4 and 5. And you can keep going, but again, you're looking for two numbers that multiply to give us 20, but also can add and subtract to give us 9. And that's going to be our 4 and our 5. So we want 4 times 5 to give us 20. Also 4 plus 5 to give us negative 9. So we want to make both statements true. Well, the 4 times 5 is 20, but 4 plus 5 is not negative 9. So can we make one or both of them negative to make this statement true? The answer is yes. Negative 4 plus negative 5 gives us negative 9. So if both of them are negative for the multiplication, it is also true. So -4 and -5 are our magic numbers. So in this purple, the result is our x minus 4 for our magic numbers and x minus 5. Now, if we were just factoring x squared minus 9x plus 20, that would be our factored form and we could start solving. But that is not what we are factoring. We were factoring actually that 2x squared minus 9x plus 10. So the method that got us here was slide and divide. Well, we slid something, now we gotta divide by something. We gotta divide by what we slid by in the green, which was 2. So in our factored form, we gotta divide by our 2, which we slid by. Then we have to ask ourselves, can we simplify 4 over 2? Yes. So x minus 2. Then we have x. We don't need to put x yet. So now, can we simplify 5 over 2? If we cannot simplify that fraction that is created for our slide and divide, then we have to move our denominator in front of the variable. So we have 2x minus 5. So this will actually be part of our factored form with the exception of our GCF out front. Our factored form is our GCF out front, then our x minus 2 times our 2x minus 5. And there is our answer for number 2 in part 3. Alright, so then the next one, we are factoring it using GCF, a equals 1, and a does not equal 1. So as we are solving, we are going to make sure one side of the equal sign is 0. Gotta have one side equal to 0 or it will not work. So for number 2, does one side equal to 0 yet? No. So we gotta add 64 to both sides. On the right, we get 0, which is what we wanted. On the left side, we want to simplify as far as we can. Is there a constant that we can combine with the 64 that we moved over? No. So there's not a like term for the x squared. There's not another x squared, so we cannot combine it with anything. The 32x, or the x to the first, not another x to the first, can't combine it with anything. And then our positive 64 stays as is because there's not a like term to combine with it. Now that we have one side equal to 0, we can ask ourselves, is there a GCF in between 4, 32, and 64? Yes, there is. It is 4. Make sure as you are going through these, you get the greatest common factor, not just a factor. If you only take out a 2, then you're going to get some funky magic numbers in trying to solve it. So if we take out 4, we're going to have 4 times 4x squared, which is the first term, divided by our GCF, which gives us x squared. Then we have our 32, and that's positive 32x divided by our GCF, which gives us 8x, positive 8x. And then we have positive 64 divided by our GCF, which is the same thing as 16, so plus 16. And then we still have the equal to 0. Now, once we take care of our GCF, the next question is asking within the parentheses, does our a equal 1? Yes. And if you want to fill it out, you can, about the a, b, and c. But now we want to create our factored form. You can do this before or after you factor what is in the parentheses. Either way, you're going to have your GCF out front, and then you're going to have 2 sets of parentheses. So let's figure out what our factored form is going to look like under or within these parentheses. So let's look at this. So our a does equal 1. So if our a does equal 1, we go straight into our big X method. If it did not equal 1, we would have to slide and divide. So our c is 16. So we want 2 numbers that multiply to give us 16, but also add and subtract to give us 8. So first number I would try is 1. 1 times 16 gives me 16. But I cannot add and subtract to get 8. So I have to keep going. 2 times 8. Well, 2 plus or minus 8 does not give me 8, so I keep going. Then 3 cannot go into 16 evenly, so I don't have to include it. 4 times 4 gives me 16. Well, I can add 4 and 4 to get 8. So those are my magic numbers. Key thing, I cannot stress this enough. Make sure that your magic numbers make both statements true. 4 times 4 to give you positive 16, and 4 plus 4 to give you 8. Both statements have to be true, and they are. So both magic numbers are positive 4s. So that means within the parentheses, I have x plus 4 because 1 was positive, and x plus 4 for the other one. So we have 4 times x plus 4 times x plus 4. So that will give us our factored form for number 2 of the 4th section. Now, the extra step from the previous problem is the fact that we have to solve or find our solutions. We are simply taking whatever our parentheses are from our factored form and setting them equal to 0. And solving for x. So we want that box by itself or that x by itself. So we have to subtract 4, x equals negative 4, minus 4, x equals negative 4. So your answer is negative 4, or you can put as well negative 4 and negative 4. It is the exact same answer. I will count either one. So let's keep going, remembering that if you have a GCF, you have to do it first. Then you have to ask yourself, does a equal 1 after you factor out your GCF? Then, if a doesn't equal 1, if a doesn't equal 1, then you are sliding and dividing, then using your big X method. If it does equal 1 after factoring out a GCF, then you're going straight into your big X method. So next section is talking about using the quadratic formula. Your quadratic formula is negative b plus or minus the square root b squared minus 4ac all over 2a. If you need to, you can go onto the site and listen to the song to help you remember it. But looking at this first problem, our a is 1, our b is 4, and our c is negative 60. So what we want to do is that we're going to substitute in our A, B, and C. So I have negative parentheses, my B, which is 4, plus or minus square root, parentheses, my B squared, minus 4, parentheses, my A was 1, parentheses, my C is negative 60. So I am only going to put in the calculator what is underneath the radical. I am not putting this whole thing in the calculator. And we do have 2 times 1. So once I put that in the calculator, what is underneath the radical, and simplify on the outside of the radical, I have negative 4 plus or minus the square root of 256 all over 2. So now I want to simplify as far as I can. You can always check when simplifying the square root to see if it will come out as a whole number with your calculator. So the square root of 256 is plus or minus 16. So that means we can go ahead and simplify to negative 4 plus or minus 16 all over 2. And this gives us negative 4 plus 16 over 2 and negative 4 minus 16 over 2. And then we can simplify these, remembering that that plus and minus is giving these two different options or these two different solutions or situations. So on the top one, when we're adding, we're going to get 6. On this last one, we're going to get negative 10. And these are going to be our two solutions for number 1. Now let's look at number 2. Number 2 uses more skills from Unit 2 that we did. So same situation, we do have to make one side equal to 0 first. So we're going to change this by adding 5 to both sides. So we get 6x squared plus 2x plus 5 equals 0. Now we can determine our A, B, and C very easily. Our A is 6, B is 2, and our C is 5. So in our formula, we will have negative B, which is 2, plus or minus the square root, B squared minus 4A, which is 6, times C, which is 5, all over 2 times A. Cannot stress it enough. There is a reason why I taught it the way I did. Only put what is underneath this radical to help you know what you need to simplify. We do not want ugly decimals when we're doing these. We want exact values. So when we put this into the calculator and simplify everything around it that we can, we have negative 2 plus or minus the square root of negative 116. And then in the denominator we have 2 times 6, which is 12. So underneath this radical, I want to simplify, or not under it, I'm going to simplify the whole radical. So the square root of negative 116, I'm going to take out the negative 1 first. Then I'm going to look at my 116 and say, okay, it's an even number. It ends in an even number, so I can divide it by 2. And I'm going to factor or find the factors creating a factor tree until I get all prime numbers. So my -1 is prime, my 2 is prime, 58 is not prime. So we can separate this out one more time with 2 and 29. 29 is prime and 2 is prime. So we are done. So this square root of 16, or -116, changes to the square root of -1 times 2 2's times 29. And then we're going to ask ourselves, what is the understood index? What is that small number that goes on this radical symbol? It should be a 2. So that means we are looking for groups of 2 of the same number, or 2 of the same thing, to move out of the radical. So there are 2 2's. I'm going to move them out. They become 1 2, or a single 2. The square root of -1 also changes to I. So there's also going to be an I that moves out. So on the outside we have 2 and an I. And underneath we have a 29 left over. When you're bringing stuff out of a radical, it is always plus and minus. So all of this means that we can simplify to -2 plus or minus 2i times the square root of 29 over 12. Lastly, we are looking at the number 2, 2, and 12 to see if we can simplify all three numbers by a single number. We can. The number 2 can go into all three of them. So we will end up with -2 times 2, which is -1, plus or minus 2 divided by 2, which is 1, which we don't have to have because it's multiplication, times square root of 29, all over our 12 divided by 2, which is 6. And that will be our answer. Alright. So then, I know that some of you are very much dreading completing the square. Remember, during the lesson, there was a lot that broke down and you could not find exact perfect numbers. So the 2 that will be on your test will work just like these 2 on your assessment review. For number 1, for step 1, we're going to move all of our variables to the left side and all of our constants to the right. So now we're going to have x squared minus 4x, and we're going to move that 21 over to the right side. So then we have step 2. Step 2 is going to be creating a constant on the left side. So in this case, our b is -4. So we will take our b, divide it by 2, and then square it. So -4 divided by 2 is -2. -2 squared is +4. So after this step 2, our equation now looks like this. X squared minus 4x plus 4 equals 21. But we just added a random 4. It is no longer both sides equal to each other. So we have to fix that. We're going to fix that in step 3. Step 3 is to take whatever we just created in step 2 and add it to the other side. So x squared minus 4x plus 4 equals 21 plus 4. So So in step 3, at the end of step 3, our equation looks like this. X squared minus 4x plus 4 equals 25. Step 4. Step 4 is only focused on this left side. We want to factor it. So to factor it, we're going to ask ourselves, is there GCF? No, there is not a GCF. Does our A equal 1? Yes, our A is right there. So we can go straight into our big X method. B goes on the left, C goes on the right, -4 and +4. So we want two numbers that multiply to give me 4, but also add or subtract to give me -4. So I'm going to start with 1. 1 times 4 gives me 4, but we cannot add or subtract 1 and 4 to get to 4. So then I go to 2. 2 times 2. 2 times 2 gives me my C, which is 4. I can also add and subtract 2 to give me my 4 on my B. So I want to make both statements true. I want 2 times 2 to give me 4. I also want 2 plus 2 to give me -4. Well, look at the addition statement. We've got to make it true with those numbers. So can we make one or both of them negative and it become true? The answer is yes. -2 plus -2 gives me -4. -2 times -2 gives me +4. So our magic numbers are -2 and -2. Completing the square is meant for these magic numbers to be the exact same. If it is not the exact same numbers, use a different method. So with these magic numbers, we did not have to slide or divide any, and there was no GCF to throw out front of our factored form. So we have x minus 2 times x minus 2, which is the same thing as x minus 2 squared. So lastly, step 5. We are going to take our factored form from step 4, and we're going to set it equal to our right side from step 3, which was 25, and solve. So to get rid of the square, we have to take the square root. What we do on one side, we have to do to the other. So we get x minus 2 equals plus and minus 5. Gonna get x by itself, so we have to add 2, add 2. X equals positive 5 plus 2 and negative 5 plus 2, which is the same thing as 7 and -3. So those are my answers for number 1. Alright, so let's do number 2. Number 2, we need to move stuff around. So step 1, we gotta have all of our variables on the left and all of our constants on the right. So we have x squared plus 14x. And we're gonna move that 40 to the other side by subtraction. So there is our step 1. Step 2, our b is 14, so we're going to do 14 divided by 2 squared, which is the same thing as our 7 squared, which is 49. So after step 2, our equation now looks like this. X squared plus 14x plus 49 equals negative 40. And I put a comma there so I can break it up so you can see it a little bit easier. Step 3. Step 3, we're going to add whatever we just created on the left side to the right side. So now our equation is going to be x squared plus 14x plus 49 equals our negative 40 plus our 49 that we created. So after step 3, our equation looks like x squared plus 14x plus 49 equals 9. In step 4, we're only worried about our left side, and we want to factor it. Again, to factor, especially using the big X method or the slide and divide method, you have to first factor out any GCF. In this case, we do not have a GCF. We also have to ask ourselves, does A equal 1? Yes, A equals 1. So we can go straight into our big X method. So we're working with 14 as our B and 49 as our C. So let's go down the line. 1 times 49. 2 does not go into it evenly. You can keep going. Typically when you see 49, hopefully you know to try 7. So 7 times 7 gives us 49. We can also add or subtract 7 and 7 to get 14. Again, when you're using the big X method, you want to check to make sure both statements are true. So positive 7 times positive 7 to give us positive 49. And then positive 7 plus positive 7, and we want 14. Are both statements true with both of them being positive? Yes. So our magic numbers are positive 7, so we have x plus 7 times x plus 7, which is the same thing as x plus 7 squared. Lastly, we are going to take that factored form, x plus 7 squared, and set it equal to our right side from step 3, which is 9. To solve for x, we gotta get rid of the square by square rooting both sides. And we get x plus 7 equals plus or minus 3. X is still not by itself, so we're going to subtract 7, x equals positive 3 minus 7, and negative 3 minus 7. So we're going to get the two answers of negative 4 and negative 10. So there is your number 2 of the last section. Remember, you need to email me or ask questions during class or via email or comment on if you need help for your Unit 3 test, which is next Tuesday, February the 18th.